I am the nature hacker, and this is your world. So, I want to talk about the noble metal battery and some caveats and some things that I have discovered about it since my last video on it. And you might have noticed that I've deleted a couple videos because I've had just, I guess, some erroneous conclusions in those videos. So that's why I wanted to delete those. But yeah, so one of those videos is saying, oh, gold is better than molybdenum, which it is, but there's a surface area issue, and it's practically impossible to get the gold to be as high of a surface area as the molybdenum. But gold will work, and if you have enough oxidizing agent, I'm going to get to that later. If you have enough oxidizing agent in the electrolyte, you can get some pretty awesome amperage out of just a small piece of gold, so you could have a gold-plated cathode, let's say a gold-plated copper mesh, and you could get a reasonably significant amperage, which is a very much smaller surface area than sintered molybdenum, but with enough oxidizer in the bath, you can easily get comparable amperage. But yeah, so. But you need that oxidizer in the bath, so I'm still mostly looking towards the molybdenum. I might use gold, like I said, a gold-plated copper mesh instead. I'm going to do some more testing with that, and once I get it might take a while, but I'm getting a charger or a power supply that's 60 amps and 30 volts, so I'll be able to do some real nice testing with that. So anyway, yeah, so the main thing I wanted to say is that you need an oxidizer in the bath, and the reason I was getting up to 1 amp with that, sorry, I'm scratching my arm here. The reason I got up to 1 amp was because, remember, like, I flip it over and oh, boom, an amp and stuff, is because that process of flipping it over and stuff introduces air into the hydrochloric acid, so that air is necessary. So as soon as that air gets eaten up out of the electrolyte, then the amperage starts dropping pretty massively. So basically what needs to happen is like bubbling air through the electrolyte or pumping air into the porous electrode. So like the electrode's porous, so you could have an air line going in there. You could have a pressurized, a fan blowing into a box and have tubes coming from that box into all of the cathodes throughout your battery system, and that way it kind of, the cathode works as like a diffuser and throws air into the mix, which is oxygen, obviously, and that allows the battery to develop amperage. And the more oxygenation, the more amperage you can draw. I mean, you can, just to test without having air bubbling, you can just add hydrogen peroxide into the electrolyte, and that works just as well, if not better. So I got that molybdenum, that little circle of molybdenum, I got that up to 3 amps, with adding some hydrogen peroxide into the bath. So there does need to be an oxidizer, or else the amperage will just drop off. So you do need an oxidizer. So yeah, basically, HCl is a very strong acid, and it's neither oxidizing nor reducing, which is perfect, so that once your air supply runs out, like let's say you shut off the fan and your air runs out, and you stop drawing a current, then your battery's stable. It's not going to self-discharge, so that's good. So, I mean, other options are actually to use oxidizing acids like nitric acid. Sulfuric acid doesn't cut it, Sulfuric acid just isn't oxidizing enough. It's oxidizing enough for lead, but it's not oxidizing enough for copper to produce a current. And but if you use something like nitric acid, as iodic acid or chloric acid, something that's an oxidizing acid, your battery will work, but it will just self-discharge. The anode will get eaten up even when you're not pulling a current. So that's why it's good to have just the strong neutral as far as oxidizing and reducing, neutral acid, and then you add in a little bit of oxidizer when you need it, so that seems to be the way to go. So, it's a natural extension to be like, all right, well, hydrochloric acid works, how about hydrobromic acid, and what about hydroiodic acid? And I tried the hydroiodic acid, I made some up, and it doesn't really work. I mean, it doesn't work with our system because once oxygen comes in, it reduces the iodine or it oxidizes the acid to I2, and so the iodine just comes out of solution as like a metal, so the hydroiodic acid doesn't work. But then the next question is, how about hydrobromic acid? It's stronger than hydrochloric, and it's not going to come out of solution once you put in some oxidizer. So I'm making some hydrobromic acid right now, and the basic recipe is roughly 60 milliliters of 85% hydrochloric acid, 50 milliliters of water, and 100 grams of sodium bromide. And this is sodium bromide you can get at the pool store, or I got this at Ace Hardware. So, yeah, I'm going to try hydrobromic acid, and it should work. It should work really well, and it should be even stronger than hydrochloric. And the cool thing about hydrobromic is you can get this stuff up to 65% concentration, whereas hydrochloric, the maximum you can get is 37%. So this stuff will be pretty powerful, and it will accept our oxidizer, like our oxygen or our hydrogen peroxide. So it should be a great acid, so I will let you know how testing goes with that. And then I want to give you some practical advice on the anodes and cathodes. Let's say you were doing copper anode, and you're using it up, and then using it, and then your voltage drops like to 0, and you're like, oh, well, I need to recharge my battery, but you go to recharge it and nothing happens. Well, that's because you totally dissolved your anode. I mean, it's not normal in a battery where the anode dissolves. This battery, the anode dissolves. That's unlike any other battery, any other rechargeable battery out there. There's no other rechargeable battery where the anode dissolves. So we have to get around this problem. The problem being, as soon as it looks like you're out of juice, you can't recharge it. So, the obvious solution is don't recharge it that much. But the problem is, you won't know that, that basically your anode is falling apart. You won't know it until the voltage goes to 0, and then it's too late. So one way around this is to take copper mesh for your anode material, and then you electroplate it with nickel, and then you electroplate it again with copper. So you have copper with nickel plating and then copper plating over it. So what happens is you eat through that initial copper plating as your battery's juice, okay? And then once it hits the nickel, it stops working. It doesn't work anymore. And I'm pretty sure that is the case. I mean, you might need to do chromium coating just so that it doesn't react. I don't know if nickel would work as an anode or not. I don't know but that should stop it. All right. That's the idea. The idea is that you're coating it with something that will stop the corrosion. So you go through your copper layer, and then it hits something and it stops it. Another option, if that works, if the nickel stops the corrosion, which I need to look into, is just using a nickel mesh and then coating it with copper. Okay, that's another, maybe easier, but nickel mesh is typically more expensive. So anyway, that's one thought there. And then the other thought is that instead of using sintered molybdenum, you can just use a gold-plated cathode instead of the sintered molybdenum. So that will also work. It might be hard to get the same level of amperage out of that just because the surface area is inevitably not going to be as good. I mean, you could say, oh, I'll just sinter copper and then electroplate the sintered copper. Well, electroplating something sintered is easier said than done, and it's practically impossible to get that gold to really diffuse through all of the channels in the sintered copper. So, but anyway, gold is another option. You know, and obviously with this hydrobromic acid, and I'm getting platinum in, and I have gold, I'm going to try a gold platinum battery with the hydrobromic acid, you know, and a little bit of hydrogen peroxide or whatever. So there will be that. You know, obviously palladium, blah, blah, blah. You can, any noble metal combo should be tested. So I'm going to be working on testing all of the combos. So that's pretty much it. I think that brings you up to date on what's going on. The main thing is there needs to be oxidizer in the acid for it to run, and that oxidizer will probably come in the form of bubbling air through the electrolyte, or using the cathode as a diffuser to you pump air through the cathode, like have a hollow cathode, and then you have like a little spigot on top of the cathode, put a tube stuck onto there, so it's kind of blowing air through the cathode, whatnot. So anyway, that should bring you up to date. I am the Nature Hacker. Do work.